This discussion is on limits. First, we'll discuss what is a limit. Now, the underlying concept here is that you're getting infinitely close to something. So you might think of this annoying game that your little sibling plays where they get their finger as close to your face as possible without actually touching you. Okay, in mathematics, we just take this to another level and we get infinitely close and we see and we investigate what actually happens there. So now we want to talk about notation. How to interpret the notation of a limit. We read this, the limit as x approaches a of f of x. In this case, you might think of this as an ordered pair or a function. So this red x value goes with the first coordinate and f of x goes with the y coordinate. Let's investigate just the first portion. The limit as x approaches 7. X is a variable, x changes. A, or 7 in this case, does not change. So this is a point here, and we're pretending it doesn't exist. We're trying to investigate what happens there. So x might take on a value, remember it's a variable, it changes, of 5. Okay, that's not close to 7, but we can make x closer to 7 and maybe make it 6, 6.5, 6.9, 6.99. As we can see, x can approach 7 from below. Likewise, we can approach 7 from above. 8, 7.1, 7.01. X can get closer to 7 from each side. Now, a limit is posing a question. It's asking you, as x gets close to 7, what is f of x approaching? And this is what we're trying to answer. So as the x value gets closer to 7, what is the y value approaching? And that's going to be the answer we're going to provide. Now, so far, we haven't seen this because we haven't seen our function. So let's look at the graphical interpretation of this. How to interpret a limit graphically. Here we have the notation, the limit as x approaches 7, what does f of x equal? We have an x value and it's changing and getting closer to 7, and we want to know, okay, what is that y value approaching? That's the answer to our limit. So first we need to be familiar with functions. They can take on any x value. Let's say x was -2. If you go up to your function, what is the y value of your function? That would be 1. -2, 1 is the given y value. Now what happens to y value as x changes? Let's say x goes along this line, x is 0, we're almost to y equals -2. Here we're almost at y equals -3, -4, almost all the way down to -5. But what do we want x to approach? We want x to approach 7. So there's two ways for x to approach 7, from the left and from the right. As x approaches 7 from the left, from below, what is this y value that we're approaching? It looks to me like that y value is 3. It looks like the y value is 3. Now it looks like that's where our limit is, but it has to agree as we approach from both above and below. So we approach 7 from above now, when x is 10, 9, 8, 7.1, 7.01. What is that y value we're approaching? It looks like the answer to the limit is 3. It is the y value our function is approaching as x approaches 7 both from below and from above. Now let us try an example. A function f is graphed below in blue. Use a graph to answer the following questions concerning limits and values of f. Write D&E for does not exist if the limit does not exist. First we have what is f of -6. So remember, in our notation x, f of x, the x value is -6. So we go here to -6 and we say, what is the value of our function? So we go straight up and f of negative 6 is the y value. So the answer is the y value is 1. Next, we have the limit as x approaches negative 5 of f of x. So an x value of negative 5 is right here along this line. Now we have two ways to approach negative 5, from the left and from the right. But we're following our function. So our function starts over here. As we approach negative 5 from the left, what is that y value we're approaching? It looks to me like it's 0. But it has to agree as we approach from the right. So as we approach this function from the right, is the y value also approaching 0? And in fact it is. The y value we're approaching is 0. And so that's the answer. Now we have the limit as x approaches negative 4 of the function. X equals negative 4 along this line. Okay, we have two ways to approach, from below and from above. If we approach from below, we go along our function, and as x gets closer and closer to negative 4, what is the y value we're approaching? It looks to me like this y value is negative 1. But it has to agree in order for the limit to exist. As we approach from the right, is the y value we're approaching still negative 1? And it is. So our answer is the limit as x approaches negative 4 of fx is negative 1. Related to this, we have what is f of negative 4. So what happens when you plug in x equals negative 4 into your function? Well, it's defined up here with a y value of 2. So notice the limit does not have to equal the function's value, although it often does. The limit from the left and from the right looks like it's approaching negative 1 from both directions, but the function actually jumps up to 2 and actually exists at 2 when x equals negative 4. Next, we have the limit as x approaches negative 2 of our function. So x is negative 2 along this line. I really want to get you used to some new notation. The limit as x approaches negative 2 from the left. That little sign up there means from the left of our function. As we approach negative 2 from the left, what is the y value that we're approaching? It looks to me like this equals negative 3. But the limit as x approaches negative 2 from the right, or from above, we use a plus sign in the superscript position, might be different. So as we approach negative 2 from the right, what is the y value we're approaching? It looks to me like this equals positive 3. If they do not agree, we say the limit does not exist, because they need to approach one y value, and these are approaching two separate y values. For part F, the limit as x approaches 0, I'd like you to do that one on your own. Now first, look at the limit as x approaches 0 from below, and then compute the limit as x approaches 0 from above, from the right. If they agree, that is your limit. If they do not, then it does not exist. Let's go to part G. What is f of 0? So when you plug in x equals 0, where is your function defined? The y value, y equals 1. What is the limit as x approaches 3 of f of x? So in this case, we go to this dotted line right here, represents the x values. Okay, and as we approach from below, from the left, what is the y value we're approaching? Negative infinity. As we approach from the right, as we approach 3 from the right, what is the y value we're approaching? Negative infinity. Now, while they agree, you can sometimes write negative infinity for what the limit equals. But infinity is not a number, It is something we approach. So, in actuality, this does not exist. Now, when you answer negative infinity, it is specifying the manner in which it does not exist. Okay, what is f of 4? So, when you plug in x equals 4, what is your y value? Well, there is a hole there, and I don't see any y value here. So, this does not exist or is undefined. The function is undefined at x equals 4. Find the limit. Is it possible that the limit exists at x equals 4? So x equals 4 here along this line. And as we approach 4 from the left, what is the y value we're approaching? Looks to me like it's negative 1. As we approach 4 from the right, it looks like we're approaching negative 1 again. So the limit exists even though the function is undefined there. Finally, we answer for what values of c between negative 6 and 6 does the limit as x approaches c f of x fail to exist. So it's basically asking for which x values does the limit not exist. We said when c equals negative 2 it does not exist because left-hand limit is negative 3, right-hand limit is 3, and they do not agree. We also said when c equals 0, when x is 0, then the left-hand limit is 1, the right-hand limit is 0, and they do not agree. Finally, we said at x equals 3, or c equals 3, as we approach 3 from below and from above, we get negative infinity, which is not an actual number. So it does not exist. And we say that the limit exists at every other point for this function. Even though we did not investigate these points here, all these points, the limit exists there because the left-hand limit equals right-hand limit. We're approaching the same value from above and from below. These points were of interest where there's gaps because they might not exist there, but it exists at every other point.